This is lesson number 3 of chapter Force and Laws of Motion. So today we are going to study about Newton's first law of motion. It states that an object remains in a state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. So here we come to know about the concept of inertia. So what is inertia? The natural tendency of objects to remain in a state of rest or in uniform motion is called inertia. This is why the first law of motion is also known as the law of inertia. So as you can see in the diagram that there is a coin kept on the piece of paper over a glass. So when you quickly remove the piece of paper, the coin is in the condition of inertia. It is not ready to change its position of rest. So when the paper is removed quickly, the coin falls down. Means it does not fly away along with the paper because of the quick movement, but it falls down into the glass. Why? Because it is not ready to change its position of rest, and this is the concept of inertia. Inertia is the inherent property of a body due to which it resists a change in its state of rest or of uniform motion. Inertia can be understood in parts, that is inertia of rest and inertia of motion. Mass is a measure of the inertia of a body. Means mass of a body decides how much inertia it offers. Heavier objects have more inertia than lighter objects. For example, a stone of size of a football has more inertia than football itself. Or a cricket ball has more inertia than a rubber ball of the same size. Examples of inertia of rest. A passenger in a bus jerks backward when the bus starts suddenly because the passenger tends to be in inertia of rest, whereas the bus is moved away forcefully. Second, when a bed sheet is flicked away suddenly, dust particles fall away as they tend to be in inertia of rest. Third, when a branch of a tree carrying a mango is suddenly flicked, mango falls off due to inertia of rest, and this is a very practical example nowadays. Now let us see the examples of inertia of motion. First, a passenger in a bus jerks forward when the bus stops, right? Suddenly, because the passenger tends to be in inertia of motion, whereas the bus is stopped forcefully. Second, an athlete after reaching the finishing point cannot stop suddenly, or if he stops suddenly, then he falls toppling head down. Third, a car takes some time and moves through some more distance before coming to rest even after the application of brakes. Fourth, a rotating fan continues to do so for some more time even after the current is switched off. Fifth, an oscillating simple pendulum bob does not halt at the mean position but continues to move further before coming to rest. Sixth, when a car or bus turns around a sharp corner, we tend to fall sideways because of our inertia to continue to move in a straight line. Seventh, it is dangerous to jump out of a moving bus because the jumping man's body is in the state of inertia of motion, but the legs are suddenly stopped by the ground and hence he topples down. Then we have one more inertia, that is inertia of direction. So what is this? The resistance of the body to change its direction of motion is called inertia of direction. For example, the mud from the wheels of a moving vehicle flies off tangentially. As the mud leaves the wheel where there is no external force acting on it, therefore it follows a straight line path tangent to wheel at the point of leaving. When a fast moving bus negotiates a curve on the road, passengers fall towards the center of the curved road. This is due to the tendency of the passengers to continue to move in a straight line. The sparks produced during sharpening of a knife against a grinding wheel leave the rim of the wheel tangentially. This is due to the inertia of direction. And in this picture also you can understand the concept of inertia of direction. So whenever the car or any vehicle, moving vehicle, is taking sharp turn, you fall opposite to the turn, and it is because of the inertia of direction.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday, and your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track, and somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion. Here's the correct definition. An object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction, unless acted upon by an unbalanced force. In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. Now, we need to look at Newton's first law of motion again. Here it is. In simple words, this means that objects tend to keep on doing what they are doing. It is the natural tendency of every object to resist change in their state of motion. If they are at rest, they would prefer staying at rest, and if they are moving at a constant velocity, they would want to continue doing so. This tendency of objects is called nothing but inertia. It's the natural tendency of an object to resist change in its state of motion. Yes, you already knew what inertia is. And yes, Newton's first law of motion is also called the law of inertia. Do you think all objects have the same inertia? All objects resist changes to their state of motion, right? So all should have the same inertia, correct? Well, not really. Because inertia tells us how strong an object's tendency is to resist change in its state of motion. Think of it like this. There's a tiny brick kept on a table next to a relatively larger and a heavier brick. Which one do you think would be easier to push? Without doubt, the tiny brick, correct? Yes, but why is that? It's because the heavier brick's tendency to resist change in motion is more. The heavier the object, the more is its tendency to resist the change in motion. The more mass an object has, greater will be its inertia. So if we apply equal force to both these bricks, the tiny brick will move further as compared to the larger brick. The heavier brick has more inertia. How can we relate inertia and mass? Inertia is the tendency of an object to resist changes to its state of motion, and the mass of an object is the measure of its inertia.
Next we have momentum. Momentum is the quantity of motion in a body, and it depends on its mass and velocity. Momentum of a body is defined as the product of its mass and velocity. So momentum is equals to mass multiplied by velocity, and momentum is denoted as P. So P is equals to m multiplied by v, where m stands for mass and v stands for velocity. Momentum is directly proportional to mass. That is, if a cricket ball and a tennis ball move with same velocity, momentum of cricket ball is more because its mass is larger than that of the tennis ball. Momentum is directly proportional to velocity. For example, if two cricket balls move with different velocities, then the momentum of the ball with greater velocity possesses more momentum. If a body is at rest, its velocity is zero and hence its momentum is also zero. But every moving body possesses momentum because every moving body has the velocity also and mass also. Momentum is a vector quantity. Its SI unit is kg meter per second and its CGS unit is gram centimeter per second. Kids, I hope you understood the concept of inertia and about the Newton's first law of motion, which we studied today. So based on that, here is your homework. Thank you.